Oh, we're live.
Oh, wow. Hi.
Hello.
So, hello. How are you?
That's Dimitri. I'm Duncan. But this is his channel, so, you know.
What?
You know that.
Yeah. So true. So, okay.
Woohoo.
Well,
So this was kind of inspired by your thing at Global Day of Code Retreat last year, 2019. Doing Game of Life with sets of things. And I thought, you very nearly made it, so we should finish it, shouldn't we?
yeah.
But starting from scratch.
This was also inspired by you doing this year remotely.
Well, that's true, yeah. And so this is TCR with revert set on, and just because it's a way of getting commits more than anything. And the constraint that I kind of wanted, well, two constraints. The other constraints I wanted was trying to avoid creating any other types, because I figure it should be possible to do it with pairs and sets and eccentric functions.
No
types
allowed.
No type allowed. A type alias, yeah. I mean, I kind of think that at some point we're going to end up with wanting to cache something somewhere, but I don't know. Let's find out, shall we?
Okay. Can we test TCR?
Yes. I don't know how, but you're the expert in IntelliJ. So
fail. You write fail something.
Oh, blimey. Oh, it's popping up on a completely different monitor.
Because, it's uppercase. Oh, sorry. It's going to take import now. Oh, God.
Yeah. Well, that's at least popping up here.
Any of them? Wow. Default searcher fail. Yay, it works.
Did it revert?
Yeah. Well, the code is done. So.
Oh, that's true. That's a sign. And can I make this go away, or does it just go away anyway? Let's do that. So my theory is that a board is a set of pairs of ints for coordinates.
Okay.
So I kind of had this theory that you should be if this was a test. Too many. If this was create board, then you'd be able to say something like val board equals set of 0 to 0, 1 to 1, and no, hold on, 0 to 0. Let's make them in a line, right? And then 0 to 1. And that should pass, right?
No, these are two duplicates.
Oh, yeah. 0, 0, 1, 0, 2, 2. Good point. So that's all there is to a board, and we should be able to run that, right?
Yeah, so the first is X. I guess it doesn't really matter, but
I don't think it matters at all, unless you actually come and render it.
We're not rendering that. I'm guessing by your reaction, we're not going to render anything.
Well, no, actually, so oddly, I've always found that at some point, I really like to render, because otherwise I find it really hard to. I mean, maybe we'll render sooner rather than later. Let's find out how we get on.
Okay.
Is there a keystroke I can use to make that test window go away? Or is that a setting on here? View mode.
Shift escape.
Shift escape, eh? Okay.
It just hides any tool window.
Right. So my theory was that if we just said that that's a board, right? Then I should just be able to say. And oddly, I don't think type alias is one of the things that it gives you at this point.
Yeah. Well, that's a good point. Yet another thing to improve in Kotlin support. For Kotlin support plugin.
So I thought I could do that, which should be fine, right?
Yeah.
And then maybe I'd say that what I really want is to be able to say board of.
Oh, okay.
And that would make us actually do a thing, right? but not there, obviously.
Oh.
Yeah, it gets a bit stupid at that point. So this is border vararg, and these are live cells.
Oh, cool. Yeah.
I guess.
And then this should be maybe a cell. Okay, let's keep it a pair for now, right? As a one step.
Yeah, that was kind of my theory. So something like that equals, and I can never remember star live cells.
I think so. Well, it's still a bit more intuitive than whatever other languages. For me, at least. Yeah.
Okay. So far, we haven't reverted anything. This is a triumph.
But we're not even testing anything. You know, it doesn't fail on compilation. It doesn't revert on compilation failure. So. What's next? I mean, I kind of feel that that's a thing. Can we then? The next thing that I feel is I want to just do straight to like whether cells live or die, right? So yeah,
cell with 2 neighbours.
That's an interesting thing. I was usually starting with like board evolves, empty board evolves to an empty board. That was my favorite thing to flesh out the whole
Right.
evolution or whatever we call it.
Step.
Yeah.
So next equals Board.step. We want to tell it. That's what we want. And once again, it gets a bit stupid at this point. What we really want to say is that this is board.
So that's one of the reasons. I mean, I understand where you're coming from with using type aliases, but their support is so bad on many levels.
Yeah.
just because of that. I mean, I would not do that. Like use type aliases extensively, just because of poor support. Yeah. But otherwise, yeah, it sounds good. Minimalistic design, right?
It's a real shame that you can't. It's a real shame you can't have private type aliases as well, because I feel like I want to be able to say you can only see this type alias within this scope.
Oh yeah. So yeah, you cannot have inner type aliases. I think you can have private in the file, but it has to be at the top level.
I think you can.
Oh really? Okay.
I think you can say that. I took a risk there and ran a test. You notice? Oh, maybe I can say private.
Yeah, but it cannot be inside the test class or somewhere else. It has to be.
Okay.
Like yeah, but I mean, I agree. It's not fully supported, basically.
And then I mean, we can cheat at this point and just and we can make an assertion, right? I've got assertions here, so I should be able to say assert true. That next contains 0 to 1.
Oh, okay.
And I'm going to use the Kotlin test. That one, I think. I don't know.
Yeah, I don't mind.
Okay, so that should pass because we haven't. Doesn't mean it's a rubbish test because we haven't tested that either of them dies. But that'll do. If it's true.
Oh, I see what you mean. Interesting.
Okay, over to you.
Oh. Good. So, can we do more, Ben, and you just tell me what to type?
We can. So, okay. I mean, I think maybe cell with 1 neighbor dies, and we can just basically replace that.
Which will force us to write some code. So if we have this,
I think you use that same board, right? And then you just say if you say next doesn't contain 0 to 0, you could. I mean, it's up to you, but.
Sorry, which line are you talking about?
I mean, had you left 20 alone, having stepped that board on, actually, it should be true that next only contains. Well, in fact, it should be assert equals set of 0 to 1.
Assert equals set of 0 to 1. Okay. Now, so we both have the same setup, and now I'm kind of regretting we're not using my new test. That would
yeah.
Why did you not plug it in? Okay. Assert equals next set of 0 to 1. That's what you mean, right?
Yeah. I mean, it just sort of keeps everything sweet.
So, oh well, I cannot run this.
Do not run that. Or demonstrate that your TCR is working.
No. One demo was enough.
So what do? We just step.
Yeah, so we want to change step. I'll put it here if you don't mind. What's the easiest way?
I mean, we could entirely cheat, and we can't even cheat and ask its size. Actually, that's what I normally do. different fixtures and just ask the size. Are we just going to have to go and write this now?
Oh wow! Okay, I thought you had a plan to do it in tiny steps. Okay, so
I mean, I'm rubbish at TCR. That's why.
It's like I don't remember now exact steps. Just for the Conway's game of life, there are like a set of tests which kind of guide you towards that more incremental things. But yeah, anyway, so what we want to do, so we have a set of 3 cells in the first example. Well, no, we can cheat. I mean, why cannot we return set of?
Oh, we can. Yes, absolutely, we can.
Yeah, so that's going to work. That should work, right? Given our tests.
Yeah.
Can I run? Do you authorize the execution?
Yeah. What's the worst that could happen?
Well, yeah.
Control R.
Yeah. So, okay. Up to you then.
So
I'm just delaying this.
So my gut says it would be really easy to mess up neighbours. So let's write a test for neighbours before we go on, which would be something like. So what we want is we want to take a pair and return what we believe all the neighbours of that are, the coordinates of all the neighbours, right?
Of a cell.
Yeah.
We have a pair which is which one? 2, 2, maybe 1, 1.
1, 1 is easy because we don't have to worry about edges.
Something like this, neighbours.
Yeah.
Then we want to ascertain that they equal to something. Well, yeah. Once again, this is not a pair. Well, ideally, we should have changed it to cell, I think. Return.
You want to type alias for cell? I think it's more type alias for coordinate, isn't it? But
okay, I'm not sure how to write a failing test. Are we confident? What should we do?
Well, I mean, so what's this? Let's make that compile.
Oh.
Yes. Yeah.
Yeah, you're right. It's just weird. Of int. That's what we want.
Yeah. So that should at least do it.
Yeah, I'll run it.
Right.
I'll save it. Can I also do type alias for cell? Maybe that's kind of halfway through, but I just feel like it is a good thing to do overall. Like that, and then everything can be. Oops, it's going to be too much. Okay, I'll do maybe 1 at a time. 2 at a time. I cannot click on things. That's interesting.
Ah.
My mouse is via tuple, so I'll save this as well. Yay. Okay. But yeah, now it's definitely your turn.
Okay, so we want to say something like assert equals. So what are we putting in? We're saying this is going to be a list of 0 to 0. So we don't. Well, let's say row column, shall we? I mean, with no real conviction.
Yeah.
2.
And this is when I miss like some kind of approval testing for values, basically. Right? Ooh. We could have written something like generate all the coordinates. Like, yeah, that looks fine.
Yeah.
This just feels like hard work.
Yeah. On the other hand, I quite like the shape of it. You know, I like the fact that you can see it.
In the middle should be 1, 1, and we should skip it, right?
Yeah.
So yeah.
2 to 1, 2 to 2, and what I've
maybe comment out. Okay.
Yeah.
Yeah, I like the way you formatted. It's like really nice. Communicates well.
So that thing should be cell neighbours, and I'm missing that. Am I?
Yeah, and it's column on line 6.
Comma.
Comma, yeah.
Okay. Do not run the test.
Well, you can hard code this value. Can you just copy paste this list off into the thing? Then we can save it at least, and then we will be kind of
good plan. Right.
We're so good at delaying any implementation. It's literally like been almost 20 minutes. No useful code.
No. Well, you say that, but I think we've got shape.
No, I'm joking. Like, yeah.
So what is this? This is our so this is our cell which has A and B. So actually, what does cell have? What does a pair have? It has A and B, left and right. I can't remember what. First and second. Yeah. So in fact, let's, in order to keep this shape, I'm going to say val row equals this dot first and column.
You could also do like destruct whatever, decomposition.
Yeah, we'll get there. So
it's also very interesting because you copy pasted this thing. Now I'm thinking about shifts. Like 0 could become -1, 1 can become 0, and these are actual shifts. I would also, what I would do actually, I would keep this list of.
Yes.
Yes. We just map over it, and these become shifts, and yeah, that's interesting. I was thinking about 2 loops, like you can have like nested loops, which will enumerate all of this and then ignore the center. But this is also really nice. It's kind of test-driven to shifts.
So yeah, my brain just stopped there. So let's. What I'm trying to do is lay this out at the moment, and keep my brain working and not run the tests. So this 0, right, is up, right? So that is this dot first -1, right? I reckon that one and that one and that one are up. Multi-set didn't work.
I think of this like X and Y.
Yeah, well, yeah, but so that's up.
Or down, because it's X and Y.
It's definitely up in the code. Anyway, let's. I'm going to try and get a thing working, and I'm just going to try and space it out, which is horrible, I know, but.
Oh yeah. If first is row, then yeah.
So I'm kind of like saying this is up, I'm just like, yeah, I don't know where I'm going with this, but I like code that is the shape of the thing that it's trying to say. And this is right. No, this is row, right? Tell you what, let's make that RW.
Oh,
I'm just trying to make things like, so that's row.
align.
That's row. And then this is column. I'm just delaying gratification because I'm scared of running it now. I don't know what right is. Column +1. You get to play with this in a minute. So this is left. This is left. This is left. So up to left, up to column, down to column, up to right. We can inline them if we decide it's rubbish, right? But it feels square root. Don't think so. Do I need to put another thing in there? Those are just RW, what I think about it, right? So we've got rows, columns, ups, downs, lefts, and rights. I mean, set out like that, I don't think I can mess it up.
Okay. It makes sense to me, but I kind of, yeah. Previous thing made also some sense to me. It was simpler.
Yeah, we may decide to inline it, right? It's certainly too big at the moment, isn't it? Shall we run it?
Yeah.
So we think 20 minutes typing that beautifully. Right. Sorry, I'm going to run it.
It was simpler. If it fails, we
undo.
Okay.
So at least we've got a list of neighbours. And yeah, do what you like with that. I mean, maybe it's just better with them all inlined, right?
Can you undo the? Can I? No. On line 43, we don't need the to debug yet, right?
Oh, is that bugging you?
Yeah. No, I'm not sure where we're going with this now. It's like I was thinking to just do map, and these were shifts. Now I'm not sure what they are. They are already the coordinates of what we have.
Yeah, those are all. Those are the pairs of where we are, right?
Yeah.
I mean so it passed, right? So we said that our neighbours were these things.
I guess you implemented this thing then.
Yeah.
Okay.
I mean, didn't do all that work and not implement it, but it's way over the top. I mean, just inline them.
Okay.
Maybe we'll like. I feel like I want to keep those.
Mm-hmm.
And then inline all these and see what happens.
Okay. Yeah, please.
Oh, what? That one.
Looks okay so far.
That one.
Oh yeah. Yeah, I see. That's what I meant basically. But then we don't, do we? I can illustrate what I meant is that we don't need, this can be RW plus, so let me just do it here maybe to show what I meant. It was, it's going to be first and second, right? Here first and then second. I will undo this, but just to show, so we could do RW plus first to CL plus second. Then we don't need to do RWs anywhere in here. And we just keep it like -1. You know what I mean there.
I think so, yes. I mean,
I have a lot. And then we go back to what we had initially.
Yeah.
So, but instead of zeros, we have this. So let me just try now and see how that goes.
Yeah, because either
Maybe
you're
I messed
right,
it up.
or if you're wrong, it automatically gets reverted, so it's all good.
Not sure
so
what's happening.
you need zeros in those, I guess.
Okay.
Zero
Yeah.
to -1.
Oh.
0 to -1.
Yeah. Okay. And formatting. How do I do this? It doesn't. Like my shortcut didn't work for formatting.
Do you want me to do that?
Oh, thank you. Also, this shouldn't be there. And if we align it, it will look nicer.
Yeah.
Well,
format it again.
Can I run?
Yeah. If you're wrong, it deserves to be reverted, and if you're right, it maybe deserves to live.
No. So, yeah, if I replace this with a space or something like that, that's even more succinct. But that's what we have initially, except that everything was -1.
Yeah. Let's inline those then, and let's use that form.
Oh yeah. Well, then it might clash this second. Oh, maybe it's right. You mean this, right?
Yeah.
Nice.
I mean, personally, I think it's less obvious. I mean, yeah, it's less obvious.
Mm.
But yeah, let's leave it.
I don't like going back.
Yeah. I feel I would have to every time I read this, I would have to know. I would have to work out whether it was right, or assume it was right, assume the test passed. Whereas whatever our previous version was, ugly though it was.
Yeah. I'm happy with this. Let's it works, right?
Yeah.
All of that. I'm happy to keep it. So.
I don't know how to format it, but I guess the answer is I put that in there for now. And I'm going to let the single expression go. Okay, so we've got some neighbours, which we spent way too long on. But at least it's a good shape. And and then we can test that with a board somehow. We don't care about edges, right? For now, we're just going to let our board grow if things go off our edge.
Yeah, well, it will be infinite, right? There will be.
Yeah. So I mean, things can end up at -15 billion or whatever. But
yeah, we could always add a thing on top and saying if it's like if you get a cell above, and it's just deleted, right? Filtered out.
Yeah.
So
Okay, so this is neighbours of a cell. So the next thing is counting the neighbours of a cell.
Yeah.
I'm going to write the test, and you can implement this time.
Although, like in Kotlin counting, it's just .count. Like, is it worth it?
No, because you've got to know which ones exist, which ones are alive in the grid.
All right. Okay. Yeah.
So if we start with this board, let's start with that board. It's really none of these things we need anymore. Tidying up while I work out what I really want to say. Okay, so so we want to be able to say something like board.count neighbours, giving it a cell. Yeah. And that I want to be 1 So this is where I just call it result. I'm going to give you a clue like that. And I'm going to say what I want is,
Yeah, sounds good.
Strictly, I want that to be one for every 101 mapped over the board. But
But you know what I'm going to do?
No, 121. Yeah.
So count neighbors. It's just 0, 1. 0, 2 is not a neighbor. It's too far. Right. So
yes.
That's what you mean.
Yeah.
Yeah. Once again, IntelliJ cannot guess correctly what we want at all. Oh well.
To be fair, that's the only thing. I do feel every time I get here that it might ask me which I wanted.
It's just typo letters. They're like basically not supported properly at all. So count neighbors, offer cell. Well, I can just return 1, right? To be safe.
Yeah. Really boots. And then I write a test.
Yeah.
Okay.
Well, at least it's safe.
So I'm going to make this worse for you, and I'm going to say result list of int board. I was just going to go. They're a list, are they? No, they're a set, but they're a hash set. No, they're a tree set, so they're in order. So I could say for each one of those things, ask you the board.
Right. Oh, I see. That's clever.
This is, I mean, this is kind of the point of having. Does that work? Hold on. No, it's board.map board.count neighbours it. That. And what I want out of this is a list of. So the first one's going to have 1 neighbour, second one's going to have 0 neighbours, and this one's going to have 1 neighbour.
Second one should have 2. Wait.
Oh yeah, no, you're right too. Yes, good point.
Oh my God, how dare I write that?
Well, you told me it was just some.
Yeah, no, just like I'll write this then. So we have board is just a map, and for each of them we do its neighbors. No, it's not a map. Sorry, what am I doing?
No.
So we just count neighbors of the current thing. Sorry, neighbors.
This dot neighbors, I guess.
I'm just confusing myself.
No, so no. So that will tell you how many neighbors it could have, and not the number that's in the board, I guess. So you want to take which one of those things? You want to take those things
and filter that's not on the board. So we're saying
this contains it.
It's not in this. Dot count, or could just count it straight away.
Hold on, surely you want this in this, it in this, because filter.
Yeah, I'm being slow now. Need more sugar. So running this, then that should work.
Yeah, I think it might.
Yay!
Awesome.
So it is just count. That's kind of what I meant. I'm not sure I like eating this. So that's a bit confusing. But it's okay.
Yeah, it's okay. Be even nicer if it's single expression, right? Because it's the law. Okay, how are we doing? We're having to scroll up already. Can we split this so we can see the tests and the code at the same time? It's a bit big, the font size now, isn't it? Can we make it smaller? Is that a thing?
Yeah, no, I would stay on this kind of size.
Okay, I'm just aware that our 3 viewers are not going to be able to see everything all at once. Okay, so that's basically a way of saying is we've got the neighbours of a cell. Cell with one neighbour dies. Okay, so this is the one we cheated with, right?
Yeah.
So now we need to go and sort out this.
Yeah, so we just map through.
So we've got a test that we just want to get passing without that.
Mm-hmm.
You say it and I'll type it.
So we want a new board. That's a safe thing to say. So
yeah,
we could just map through whatever we have this map. That will produce us a list. Oh, okay.
Each one of those things is a cell, right?
Yeah. I think this will produce a list. So at the end, we have to say to set at line 61.
Yes, good point.
Just to make this kind of compile. So, oh, why is it not happy? Oh, because it's not clear what we map into. So yeah.
Okay.
So inside there,
so if I said cell to cell, that would be fine. Just don't run it yet.
Yeah, so at least that's not wrong. Then we really want to create a different set of cells. So it depends on how we want to do that. Right now, I think filter will do, really, not even a map. I think that was maybe premature. We're not bringing any cells to life. So and with cell.count neighbours, these count neighbours, I think. And then cell. Yeah, count neighbours. Cell. What we had, greater than or equals to 1, or just 1, or greater than equals to 1. Well, what was the example again? Just one cell with
so
two neighbours?
We only asked the question. So we haven't shown that these. Okay.
Right. So we have to say that it has to be greater than 1.
And at some point, less than some other number. Feeling lucky?
Yeah. Yay. Well,
okay.
We don't need to set, I think, now at the end. I'm not sure. We could simplify all of that, probably. Not sure if we need.
Still gives a list.
We don't need it. Okay.
I'm just going to take these away, sort of out of our face, because they're not very interesting to anyone anymore.
We're done with them.
Yeah. Okay, so cell with one neighbour dies worked, and sort of tempted to try and get rid of these out of our face as well. But cell with two neighbours lives. Shall we? Tell you what, let's pull those. I'm just trying to keep all the code in one place so we can see everything. In fact, I suppose we could, what is it, a fold?
You can still do, I'll do it. You can still do command minus, and that collapses everything.
Good. Right.
Or even this, and then we expand only what we want. I'll just run it, so we save your rearrangements. Yeah.
So step is the thing that we now want to do some things about. So we've got cell with two neighbours lives, cell with one neighbour dies. Shall we? So we've got two different tests here, haven't we? One is let's just inline that because it's not really doing anything for me. So that one.
I agree.
But cell with two neighbours live. So this one will live, and so this should in fact be. Well, we combine these. We've got the same. We've got the same setup here, right? So this, in fact, this is saying nothing that this one isn't. Because this is saying it contains this, but this is saying it's exactly that. So this is just a strengthening of this one. Do we need two different tests for it, or do we not?
It depends on your preferences. Yeah. I think they kind of test into different things, I suppose.
Well, they're saying two different things.
Yeah, but they could test it. I mean, I don't mind. Like, yeah,
my gut says, let's, unless we're going to write tests for the say, right. Shall we write some tests around how many it takes to live or die? And then we could get rid of this one, safe in the knowledge that we basically just have to show that the board is the generation of the death rules, right? Or the live rules. So I maybe cell with 1, 2 neighbors lives should be saying not creating a board, but it should be testing a function that says if you're alive and you have 2 neighbors, you're alive.
Okay, I'm not sure what you mean. Maybe.
Well, I guess what I'm saying is that what we these are both testing this expression, but we know this expression is going to get hairier. So
not by much, but yeah.
Not by much. No, I agree, not by much. But I can't remember what the rules are, so I'm going to have to do something.
I think I'll look them up. I think it's 2 or 3, then it stays alive. Otherwise, it dies of overpopulation.
Can we make this thing a function? I'm thinking something like fun. Even if we don't have the board, so if we have the function would be something like should be alive, right? So the question is, am I alive now? But I don't know whether it actually cares about that. And Boolean. I'm a Java programmer. And neighbors.
Okay. That's what we kind of have above. And I think all we were missing is really just one more test, say like cell with 3 neighbors leaves, cell with 4 neighbors dies. And then we cover all like 1, 2, 3, 4 of neighbors.
Yes, I don't know whether it's alive now matters at all or not. I can't remember the rules.
There is a simple, if there is a cell and it has 2 or 3 neighbors, it stays alive. Otherwise, it dies. So it's 2 or 3. We have covered 2.
Are you happy to just write that here?
I'm not sure why we need this function.
Well, because I was going to test this, basically. I was going to write a test for this so that we didn't have to keep on building boards that showed the state, but maybe building boards that show the state is fine.
A neighbor count is in this range. That's all. And if it's alive, I suppose that's what you want, right?
Yeah. So I don't know whether it matters, but this is, so is it alive is board this dot contains.
We are going through the living cells. We know that it's alive because we're going through the cells which are on the board. So this is
it's a very good point.
Is alive equals true, and that's just
this counts
neighbors.
Yeah,
and that's why I was saying like I don't see like a massive point in this function right now, but maybe in the future, like if you want to have all rules in kind of one place, I suppose that's what you want, right? I'm running it. Interesting.
Lucky guess.
But we just don't have a test. So do you mind?
We don't have a test. Yeah. So the question is either
I want 2, I want 3. Do you mind?
No. Let's do them with boards. Let's not test the function separately. I'm happy with that.
Okay. And then we need 3 neighbors, whatever. I'll copy this and do -1 in some dimension. And then we are, it's interesting. What are we testing? Oh yeah, okay. Maybe if we focus on 0, 1, then we add one more point around 0, 1. And it will be, let's say, 1, 1.
1, 1.
So that's definitely within the reach, and we still say it contains. So 1, 1 has 3 neighbors now, does it? Yeah. Oh, 0, 1 has 3 neighbors.
Yes.
I'm not sure. Like, I'll just run it and see if it works. Yay, it does work. Then we want to make sure that 4 neighbors means dies.
Yeah.
And we should already have this functionality, so I'm just adding tests. Oops. It's 4 neighbors.
Really bugs me, these 4, 3,
1
2.
more neighbor. Oh, sorry?
I was saying it bugs me that you're going 4, 3, 2 on that rather than 1, 2, 3.
Yeah, I'm going to -1. All I'm doing, and like that's the cell, and I'm decrementing this one.
Yeah, that's good.
It's
and then
confused, but
not contain.
does not contain. Basically, we want to say does not contain. Maybe I'll do this thing not in again. Not in. Okay.
Okay.
Yeah, it still works.
Do you want to
So
formulate this one the same way?
Yeah. Oh, let me test also maybe this thing. So say if we do 1 and 4, that should revert, right? Just to kind of make sure this was actually failing. Yeah, it was. So good. So the right end of the thing is failing, or maybe also 1, just to make sure that this range is valid.
Yep.
Yeah, so this all works. It goes back to 3.
Nice.
So that's cool. And then all we need to add cells which come to life, basically, from here.
Yeah. And make these in the right order.
Yeah.
It's really bugging me. It's bugging me more than it should do.
Yeah, I know. I was aware that I'm doing it in reverse order, but that's what they were, so I just went with the convention.
That wasn't a convention, that was an accident. Okay, so cell with 1 neighbor dies, cell with 2 neighbors lives, cell with 3 neighbors lives, cell with 4 neighbors dies. Okay, so
so it should all work. I'll run it if you don't mind. The real problem I have with this test is like they're really hard to visualize, so that's why it might be worth like later refactoring into more visual boards.
Yeah.
So we can actually see things.
Okay. And then I feel that so it's, which one is it? It's an empty cell.
Yeah. 3 life goes to life. Exactly 3. So we can call it dead cell. Dead cell with 3 live neighbors, but it's also an empty space, really.
Yeah. So yeah, well, yeah, whatever. It's cell. It's good. So so in fact we had this one here had 3 live neighbors, right?
Then press clean to restart.
So if we took that one and then just took, so which was the one that had 3 live neighbors? It was 0, 1. So in fact that test should be the same if I took out 0, 1. Agreed?
Yes, I agree.
Okay, but we can't run that yet.
Don't run it yet. Don't run the test.
Okay, so now this was kind of where you got to in.
We did it faster, for the record.
Yeah, well, you didn't faff around with my silly count neighbors, did you?
No, it was all good.
Okay.
So now we want to go through all the cells neighbors which are dead. We want to find all dead things. Maybe we want to write a function like we had neighbors of a cell. We want to say dead neighbors. I don't know. That's an interesting thing, because now, like this count neighbors, it's really count living neighbors, right?
So we've already got neighbours right here.
Yeah.
So that feels helpful.
Yeah. So what I'm proposing is kind of, instead of count, have a filter. So I'll just show it in the code.
Yeah.
So what if we had a thing called live neighbors, which is just that filter, and then like change the type to whatever it wants to. Then we can have, live neighbors. Neighbors. Then we have dead neighbors, which is reverse of that kind of. Dead neighbors, then it's like not in this. Right. Then we can replace this with live neighbors count, and then we will have dead neighbors. I don't know if that's correct. So we have all the neighbors of the cell, then we make sure none of them. Yeah, so something like that. That's like as a refactoring. Is that okay, you think?
Yeah. So if you, well, I mean, it feels to me like if you just commented out a test right now and then implemented that in terms of that, that would be okay, wouldn't it?
I was going to do that, if you think that's okay. So one of the function is not used, the other is used. Do you mind?
Oh, good. Oh, hold on, but you were about to revert.
Oh, I'm
because you
sorry.
still had the test.
Oh God, you told me, and like, damn it, your new brand new test. Okay, I'm not cheating. I will have to type it again. What was it? Cell with 3 neighbors.
Dead cell, yeah.
It'll be better next time. Dead cell with 3 neighbors comes to life. And then it was, you removed this one.
Heard that one, yeah.
That contains, sweet. So that's an interesting
now
thing.
commented out.
Yeah. I agree. Now we can do this thing again. So my plan just was to make it a bit more clear about which cells are live or not.
Yes.
Live neighbors.
Yes, because yes, cell is really just coordinates, isn't it?
Yeah.
So it's the board that brings coordinate to life by having it. Ooh.
Then even count neighbors becomes kind of redundant, I feel, because it's just count. Right?
Yeah.
That's a thing. And then we can have dead cells. And that should give us some kind of grip. We can even start adding them without test. That's another interesting aspect. So nothing stops us from that.
No.
The dead neighbors, but not in this. So now we will have dead neighbors. Yeah. Maybe I would reformat this a bit, if you don't mind. It's like filter.
Yeah.
Oh, that's too long. That's okay.
Yep.
I'll run that. So we want this filter plus a set of something, right? In theory. And this set, we go through all the things that we have now, through all the cells. For each cell, we get dead neighbors. Why not? Empty set. Oh yeah, I see what's going on. I think it's because map will return a list.
Yeah.
So let's do map it just to make the signature work.
Yep.
Map it to set. That's happy thing to do. Compiler is happy. And then for each we want neighbors. Dead neighbors. Oh, do we have that? Why not?
Because you have to ask the board.
It's a board.
Yeah, it's interesting whether it should be board live neighbors of cell or cell live neighbors on the board.
Then from dead neighbors, well, that's maybe a flat map then. For now. Maybe overthinking it.
You can't see it. It's on my other screen.
I think my
Hit enter.
tuple is frozen for me, Duncan. You have to help.
Right. Okay.
Then
okay.
for all dead neighbors, we want to find their neighbors and count them, right? So, dead neighbors, we want to just filter them. All we want is the newborn cells, they come from dead. So we just need to, at the end of dead neighbors, we need to filter them, right?
Right. Hold on. So these are putting in all the dead neighbors at the moment. So that will make everything fail, right?
Yeah.
So what you're saying, yeah. And I can't find a way to format this either. That's good, but let's just go here for now.
Yeah, that's
a little bit better. Okay, so we're saying we want to take the dead neighbors and we want to filter. So this is dead neighbor. Well, it's a cell basically. And we want to filter it if the live neighbors of the cell 3.
Dot count. That's it, I think. Well, we'll see when it fails.
Yeah. So we are not going to copy this code. I'm going to run it. Run it?
Yeah. Oh no.
Oh, what went? Cell with 1 neighbor dies. Did we bring it back to life? No, we can't have done.
What was it? Can you scroll on the right-hand side? Oh, but actual 0, 1. That's interesting. So we also get assert equals the other way around. That's why our expected is the whole set. So our neighbor filter didn't work. So it was actual was all the cells, right? Oh, well, that's not wrong. That's the problem. Our test was very specific. All our other tests, they were very good because they were like about contains. Right? And this one is probably correct if you look at the coordinates. So it's like expected and actual the other way around. So we got cell 1.1 brought to life, and that's correct because it has 3 neighbors.
No, none of those have 3 neighbors.
Oh, it does. No, maybe not. So
I mean, this is true, right? We do expect that to be true. Nothing should be created here. This one should die. No. This one should die. This one should live.
But there is one more cell around them which can come to life because these are 3 cells in a row.
So above and below got created. Yes.
But I'm not sure why 0, 1 is in the set once again. That sounds a bit strange. That looks wrong. That 0, 1 was in the set.
No, because it doesn't die.
Oh, yeah, true. Yeah, of course. Yeah, so it actually is correct. I think it might be that this is just correct, and our test was too specific.
Yes. Okay. So let's just go and. So somewhere here in died, you did this one, right?
Yeah.
So let's make that this one.
Yeah. I think that would be better.
Right. Can I run that?
And I'm happy to type everything again. Maybe. Okay. Oh, what? Oh wait, sorry, it was wrong. 1 cell with 1 neighbor dies. So I guess it should have been 0, 0. Right. So it was a different example. So here we have.
Yes.
So it should have been 0, 0. Or 0, 2.
Yes, in fact, what we've made here is we've made the blinker thing, right? The one that goes from a line that way to a line that way to a line that way to a line that way.
Oh, yeah, you're right. True. Yeah, that's the blinker. So yeah, should I try and type the whole thing again?
You know what? You tell me. I'll let me see whether I can reproduce what we had. Okay. Right.
So yeah,
this is this was
flat map.
So we're taking the board and we're flat mapping it. Yeah.
Yeah. And that's a cell. Let's say. Then for each cell, we find all the dead neighbors. So like, oh, it's the dead neighbors of a cell. Sorry, you see the APIs.
Yeah, dead neighbors of the cell. Dot live neighbors.
We want to filter, so we only want. No. Now we filter because we add into the set only the dead neighbors, but not all of them. So we need to filter them out. Some of the so it's a dead cell, let's say. So because we already have cell, it's going to shadow the name. That's a dead cell. And then we count live neighbors of the dead cell. Yeah.
Live neighbors of the dead cell.
Yeah, but then this is where your function comes in, right? Should be alive. That's where we should refactor this to with the dead cell later.
Yeah.
To keep it continuous.
And this is complaining that
dot count after live neighbors.
Yes, thank you.
I think that's it. Hopefully this time.
We're not going to cheat.
Well, yeah.
That was the only thing that failed last time, and we probably typed the same thing. So yes.
Yeah. Well, the second time is better. The naming is better. I would say it's not no eat. It's dead cell, and so on. Yeah, that's the ultimate test. Run. I think we've already seen in our previous failure that this would pass. Not really. No, yes. Actually not. If only we had the same fixture everywhere. Yeah.
And it should. Where was our cell with 0 to 1 and 0 to -1? In fact, right?
Maybe the example I like. Yeah. I don't like this example now. This setup. It can be confusing. We should go with the blinker. I think that's a good observation.
So that is this. So in fact, what we're kind of saying is that assert equals. Well, I'm just.
No.
This is set of. So this is -1 to 1 and 1 to 1. Board.step, because that's our blinker, right?
I guess I cannot. Okay.
I'm willing to give that a go. Oh
no! But what's it trying to achieve?
Well, so we said that this.
It's a different example. That's the problem, yes. Right? Yes. We should have done I should have done 0, 1. Yeah. Sorry, go on.
Yeah. So that was 0 to 1, and that was 0 to 2.
Yes, then what you said is correct. It's going to be it should blink basically.
Yeah. This we decided.
Can you do it?
No.
Oh, nice.
Gonna get there.
Okay.
So once again, we think this should be -1 to 1 and 1 to 1. The one that's up here and the one that's down here.
Wait, but what do we have in the failure? You can just see. That's what we had, right?
Yes. Yes, let's type what came out the failure.
But that's not a blinker, then. It's not going to blink. Oh, no.
Still not.
We literally making no progress.
I hate TCR. So we're saying that this passes, right?
Oh god. Yeah,
we must be in the place where it lasts around the test.
okay, good.
What else
Well,
is
let's
it?
do one step at a time. What if we do this? Does it still also contain cell with 3 neighbors? No, we want it on the line below, so it will be like 1, because it's just like somewhere 1 off. I'll try this.
Yes.
And I still, to be honest, I wouldn't rewrite this test because I like that they're very focused.
Yep.
And also maybe it's worth rewriting it in with this in thing. Yeah, that's probably in line with what we have. Well, not everywhere, but in some places. Oh, okay. It was me probably just doing that, and you did it the other way around. Okay, so I just rewrote it like that. But look, I'm not sure what you were trying to do. You wanted to bigger example.
No, not much. I mean, so the next thing is probably to write a glider, right? But I can't be. I need a board visualization to make that work.
Do you mind a small refactoring at least, like to get this should be alive in, because I felt like that's what it is. You wanted to encode the rules, so this should be false. That should be that. Right. And that's. Then we need to implement this logic now. If it is alive, and neighbor count, or how do you want to write that? I'm not sure. Or not alive. I'm not sure if it's gonna look nice or not alive. That's kind of obvious. And neighbor count. That will work. But I'm not sure that's kind of slightly confusing because these are different neighbors in some way. But I don't mind. On the other hand, all the logic is here. That's like that. But IntelliJ won't let me to keep this formatting.
I mean, there seems to be a smaller formulation of that around. I mean, that's the rules as we state them, right?
Yep. Yeah.
It also feels like there's a formulation around if your neighbor count is 3, you're always alive. Otherwise, you're alive if you're alive for 2, and you're dead otherwise.
Yeah, and there is a problem with this implementation. It's like not efficient because it will go through the same neighbors again and again.
Yes.
So that's also not the best way, I guess, to write this.
And so I am tempted, but not now because it's coffee time. To just it feels like the board should be able to optimize it. Like having just board as a board and cell as type aliases mean that we can't store anything, but a cell could remember its neighbors because you keep on asking that question, for example. So if cell was actually a class, it could have a late init set of neighbors, and because a cell is carried over from generation to generation, we would have to we could keep on calculating neighbors for it. For example, it would already know after generation 1 where its neighbors were, and so on. So it feels like maybe we'll come back to this and see how quick it is and how we can make it quicker. I like the type aliases.
Yeah, can I do one thing that bothered me all along? What about that? Is that a reasonable test, or should we maybe?
No, that was a test that was moving us along. I think you can go now, right?
Oh.
That was.
Can we delete it, or
delete it.
Okay.
Interesting thing came up over the weekend at where we're at Calgary Day of Code thing around we were mobbing, and I think it's Llewellyn said when you need a function. So when you need a function, don't go and define the function first. Write the thing as if you need it in the place where you need it. Yeah. And we always do that, right? We very often say, okay, I've got this function. That was what we wrote up here, right? So we'd written a thing that said, I want this thing to exist, and now I'm going to bring it into existence. And we do that. I mean, we do that just because we TDD people, and it feels like it counts as a failing test. But one of the nice things was that mobbing kind of forced you to do it, because if you're about to drivers or navigators, whatever, if you're about to change, writing where you want to use it and the parameters to it and so on is a way of telling the next person what you wanted it to be, whereas just writing the thing doesn't tell them how you wanted to use it. And I thought it was quite nice little way of using a marker of sort of setting out directions before you go on. Because we had that problem with Mob, don't we? That like you get to this point and you go, well, I don't know what you're trying to do. What were you trying to do?
Yeah.
I quite like this. I quite like the fact that you can do it with no classes at all.
With no classes. Oh yeah.
Yeah. Well, I mean, yes. This is entirely. I mean, this is like a closure programmer, isn't it?
Yeah. If we actually look at the actual implementation, I mean, of like the meat of it is just that bit plus that bit. So that's the whole implementation, right? That's kind of the implementation from here to there. Yeah, admittedly, this is a bit kind of heavy.
Yeah,
but it's quite straightforward, I would say. This is a bit like tricky, but not really. Just
I want to say that this is private.
Oh yeah,
nobody cares. So this is our interface.
Should it be at the top then? Yeah. Yeah.
That's all right.
Yeah, I'm not sure about step. It's also a strange term. I mean, it kind of makes sense, but maybe it should be .next or something like. Don't know. Yeah, I'm also not sure about like the structure of tests. I think that we had some tests which are for a cell really, and others for a board. If this count neighbors. Oh no, it is for a board as well. Oops. Yeah, this one is for a cell. Yeah.
Yes, I mean, and that one might go away now, I think. I mean, if everything else works, that does, right? We wrote it. One of those.
Run it then.
I mean, yeah. I can imagine breaking that code, but the nice thing about laying things out like this, compared to the other way, is that you are incentivized not to mess with it, right? You. Right. Shall we call it and maybe come back to it another time and see whether we can run it quicker or something? In fact, we should add a thing to actually run it. So, so basically,
just continue on this code base and just.
Yeah, I think so. It would be nice to. It would be nice to have a thing to print a board, like parse a board from a string, print a board to a string, and then generate a sequence of iterations of a board, right? And then we could, then you could actually see it running.
Yeah, I would vote for visualizing it so we can visually verify it.
Yeah, yeah. And then, yeah, I'd like to see how often we actually reevaluate neighbours all the time, and yeah, it's got to be quite a bit of dead code in there. But now it's really functional. It should be easy to memorize all that stuff, right?
Okay, tomorrow then. Tomorrow morning.
Yeah, now copious free time. That was fun. Thank you, and thanks for being available at short notice. Because otherwise, I would have done this on my own and not managed the flat map.
Yeah.
Right.